so we are going to look at rotations. So it's our last of the isometry, so rigid rotations or rigid transformations or congruent transformations. So it's just changing its location by rotating it. So a few things to take note of is that when we're talking about a rotation, it's always going to be rotating about a center of rotation. That's where it's rotating around. We are going to focus on rotations around the origin. And then we also have something called the angle of rotation, which is how much it was rotating. So here's our original point, so making a line from our original point to the center of rotation. And then if we have a new point, a line from our center of rotation to that new point, this is what creates our angle of rotation. So we're going to be focusing solely on 90 degrees, 180 degrees, 270 degrees, and 360 degrees. So as we're looking at our rotations, what we have here are based off of counterclockwise rotations. Ooh, that's kind of funny. But counterclockwise rotations. So you have two options. Option one, you can see it as the quadrants. And so a 90-degree rotation, it just moves counterclockwise to the next quadrant to the left or underneath and so on and so forth. We're also going to talk about what that would look like clockwise. So everything that's clockwise has a counterpart that is going, everything that is counterclockwise has a counterpart that is clockwise. So if we're talking about a 90-degree rotation clockwise or counterclockwise, that's 270 degrees clockwise. 180 degrees counterclockwise is equivalent to 180 degrees clockwise. 270 degrees counterclockwise is going to match up with 90 degrees clockwise, and 360 is going to match up with 360. So that's something to notice first. The second thing, we're going to do a little bit of practice. So just like yesterday, or just like with reflections, how there were certain ones, there were 4 that to help remember, little rules you can help remember. There are rules as well when it comes to our degrees of rotation. So 90 degrees, 180, 270, and 360. Again, all of these are counterclockwise. And here's our different changes. So I'm going to start with a point, and we're going to start with the point of, let's say it's -2, 4. And we're going to go through practicing those changes, what that point would look like through different rotations. So looking at this point, our 90 degrees counterclockwise, or it's 270 clockwise, here's our change that happens. It's original point of -2, 4. What's going to happen is whatever is in our y spot is they're going to switch places, and it's going to be the opposite of y. So that new point would be -4, -2. If we're looking at the 180 rotation, here's our original point. Our new point, x and y, stay in their same location. It's just opposite signs. So we're going to have a +2 and a -4. A 270 rotation that's counterclockwise, meaning 90 degrees clockwise. They're changing their spots because we're making a rotation that is into a different quadrant, like a different even or odd quadrant. That's how I like to think of it. If we change from quadrant 1 to quadrant 2, we know that our x and y's are going to change spots. If we go from quadrant 1 to quadrant 3, then our x, y's are going to stay in the same spot. It's just signs that are going to be switching. Okay, so looking at the 270 counterclockwise, our numbers, our x and y are switching spots. So 4, and then our x value, when it changes its sign. So 4, 2. And the last one, 360 to 360, is staying the same. So it's -2, 4. So this is a lot, I think it's a lot easier to kind of see that representation as we go through visually on a graph, because we have all these little helps and cheats, but it's easy to see it it's easier to see it on a graph. So we're going to look at a few examples. We have 3 examples that we're going to look at. We're going to call this A and this B for the graphs. So we're graphing our quadrilateral. Here are our original vertices. And then for part A, we're going to rotate it 90 degrees about the origin. And then part B, we're going to rotate it 180 about the origin. And we are going to do, it's going to be counterclockwise rotation. It doesn't say it in there, but we're going to rotate it counterclockwise. So I'm going to give you a minute. Go ahead and copy down the original, and then we're going to go through the rotation. Okay, so now that we have that copied, I'm going to make this a little bit bigger so we can see it a little closer. So what we're looking at for part A is a 90-degree rotation. And if we think back to that shortcut we just had, it's negative y and then x is what we do to our change. So if we look at it visually, we have one of these points that's super easy to figure out that rotation just because it's on an axis. So that point D, if it's on an axis and it's 90-degree rotation, it's going to the next axis we have right here in that counterclockwise. So D prime. There's our first one. That one's pretty easy, and then we're going to go through the rest. If we're looking at quadrant A, so something just to think about. Everything that is located currently in quadrant, this is quadrant 2. If it's a 90-degree rotation, it's now going to end up in quadrant 3. Everything that's starting in quadrant 3 is now going to be in quadrant 4. So if we're looking at our new A prime sign, we are going to, it was starting at -2, 4. And now following that rule, we're going to be at -4, -2. So -4, -2, right there, A prime. If we're looking at B prime was starting at -4, -1. So our opposite of y is coming first, and then our x is coming second. So 1, -4. We talked about how if it was starting in B, it should starting in quadrant 3, it should now be in quadrant 4, which is correct. So we are good there. And for C, we're starting in quadrant 3, so it should end up in 4. It's starting as -3, 3. So it's the opposite of our y, so 3, -3, which is right here. It's exactly where we thought it should be. So we can connect those points. Hopefully yours is a little bit better than mine. But then we can still see it's remaining congruent, so it's keeping that integrity of the congruency. Okay. Our next one is a 180-degree rotation. So if we're looking at a 180-degree rotation, it's keeping our x and y in the same location. It's just the opposite of each of them. So what we're doing, if it's an 80-degree rotation, that means it's moving 2 quadrants. So A should be in the next one, B and C should be in quadrant 1. And nice thing for D, it's on an axis, so this would be 90 degrees, and so 180 degrees would bring it here. So then we're going to look at A prime, B prime, and C prime next. So A prime, it is the opposite of what we had, so 2, -4. For B prime, it's the opposite of what we had, which is 4, 1, which it is in the right quadrant that we need it to be in. And C is the opposite, so 3, 3, which again is in that correct quadrant. That's something to always kind of think about. Just a way to double check yourself as you're going through to solve to see, is it in that same quadrant? And then looking, is everything maintaining that same distance, B to C, C to D, A to D, all of that good stuff. Okay, our last one that we have for our example is, is rotating a trapezoid. And we are rotating it 270 degrees about the origin. We're going to do counterclockwise again. So I'm going to give you a minute. Go ahead and pause and do the original, and then we'll talk through that rotation. Okay, so if we have a 270-degree rotation counterclockwise, then that rule is that we have X and Y are switching places because it's an odd rotation, and our X values are now opposites. So P's original point was 2, 5, so now it's going to be 5, and then the opposite of X, so 5, negative 2. So 5, negative 2, there is my new P prime. For Q, Q was 4, 4, so they are switching spots, so still 4, 4, but our X values are opposites, so 4, negative 4, 1, 2, 3, 4. And we can do that same trick that we were doing earlier. 270 would be 3 quadrants over. So if it's starting in quadrant 1, it'd be 1, 2, 3. So they should be ending in quadrant 4, which is exactly what we have here. And then when we graph R and S, they're starting in quadrant 4. So it should be 1, 2, 3 spots over to end up now in quadrant 3. So if you look at point R, it's starting as 4, negative 1, so they flip-flop their spots, and X changes when it gets to its new spot. So negative 1, negative 4 for R prime, and for S prime, they're flip-flopping their spots, and our X value, when it gets to its new location, changes its sign. So negative 2, negative 2. And if we look at the picture of that graph, we had an isosceles trapezoid to start, and we have an isosceles trapezoid to finish. They've all rotated 3 quadrants over, which for that 270 degrees. So we're doing all those little checks just to make sure it is done correctly, it stayed congruent. Okay, and that is all of our examples for today. We're going to work on a little bit of homework, a little bit of extra practice after this.